Hi everyone, this is Madison Mullen, and I'm presenting on an article called Aerobic and Anaerobic Determinants of Repeated Sprintability in Team Sport Athletes. This is an article that was published in the Biology of Sport in 2015, and this is under our weekly topic, Repeated Sprint Ability. So to give a little bit of background, in our lecture this week and as well as in this article, repeated sprint ability is defined as the ability to repeat high-intensity, short-duration efforts followed by a short recovery period. So really the key is that there's a short work period followed by a short recovery period. And a lot of our research that exists now shows that repeated sprint ability is related to VO2 max. And that's likely because with a higher VO2 max, you're able to maintain a high level of performance for a longer period of time. Greater lactic acid removal and replenishment of PCR stores allow you to maintain the high effort, even within a short recovery period. Conversely, other studies indicate that there's actually a strong contribution to anaerobic fitness as well. So the ability to remove blood lactate has also been a possibility in contributing to RSA performance. Additionally, RSA has been measured using the Wingate test. That's pretty common, but it's received some recent criticism because people say that it's not that applicable to intermittent sports and team sports, which is what these authors were particularly interested in. And then more recently, they validated a maximal anaerobic shuttle running test and its ability to test anaerobic fitness. So they wanted to see what those performances and how those related to a traditional RSA test. So Gharbi et al. Asked, what is the relationship between differing RSA indices in both estimated VO2 max and laboratory and field anaerobic fitness tests? So that's kind of a mouthful. But it basically is saying, what are the determinants of repeated sprint ability in relation to aerobic and anaerobic fitness? So method, they used 16 college-age male athletes, and they had a requirement that they needed to have at least 5 years of competitive experience. They wanted well-trained athletes. They used 8 soccer players, 5 basketball players, and 3 handball players. This study was conducted in Tunisia, so handball must be a big sport there. But they collected data on height, weight, age, BMI, body fat percentage, and estimated VO2 max before conducting any of the tests. And then participants performed one of 4 repeated sprint ability tests or aerobic and anaerobic fitness tests as a part of the study. They only performed one in a single session, so there was at least a 48-hour period between each. They had plenty of time to recover and that kind of thing. But before performing the actual tests, they had a 15-minute warm-up period, and they also had some familiarization as well. So they knew exactly what they were doing when they were actually recording data. Heart rate was monitored throughout the tests, and blood lactate was also measured 3 minutes post-test for each of the RSA tests. Okay, so let's go over the 4 tests that the participants completed. First was the standard repeated sprint ability test. So this kind of falls under that definition we talked about earlier, but they completed 10 repetitions of a 30-meter shuttle sprint, followed by a 30-second passive recovery. So a very short work period, followed by a very short rest period. They also completed a 20-meter multi-stage shuttle running test, so that's the MSRT, and that was a shuttle run between 2 lines, and they had to match the pace set by a computerized like calibration beeping, and each minute the velocity would increase about a half a kilometer per hour, so in miles per hour that's about 0.3 miles per hour each minute. And when the participants could no longer keep the pace, or they couldn't reach the end of the 20-meter on beat, essentially, that's when the test was ended. The maximal anaerobic shuttle running test, or the MASRT, which I mentioned earlier, was a shuttle run for 20 seconds from the start to the finish line, in line with some audio beeps emitted from the computer. So they had to leave and then make it or stop sprinting at the end of the 20 seconds, according to the pace set by the computer. And that was then followed by a 100-second passive recovery. And actually, just as we're looking at that, you can see that a 20-second work period to 100-second rest period is much different than the repeated sprintability test. So we'll talk about that in a little bit. And then finally, they completed a Wingate test. So standard protocol, they had a 5-second pickup before the power or their resistance was applied, and then they maintained that high intensity work period for 30 seconds. And then they actually measured peak time, total time, fatigue index, sum of all the sprint times, and their best repeated sprint performance for each of the running tests using a photocell beam. So that's how they recorded all of their data. So researchers found, after using a Pearson correlation for each of the indices, that there was no significant correlation between any of the RSA indices and the Wingate test, which is what they were expected to find. And that's why the Wingate has received the criticism that it has. It doesn't appear to be related to, or Wingate performance doesn't appear to be related to repeated sprintability performance. The MASRT, so the anaerobic shuttle running test, yielded the only significant correlation to repeated sprintability, specifically the total sprint time and the fatigue index. But that was actually a negative correlation. Although it was significant, it was a negative correlation. And that could be explained by the contribution of aerobic metabolism, because the rest periods were 100 seconds and not 30 seconds like it was in the RSA, the standard RSA test. There was more time for lactic acid removal and PCR restoration. And so that could maybe explain why there was a negative correlation there. And then only the repeated sprintability test found a significant correlation with the estimated VO2 max, which I had discussed earlier. In terms of blood lactate levels, there was no significant difference between blood lactate levels following the maximal anaerobic shuttle running test and the Wingate test. But the repeated sprintability test did yield significant difference between pre- and post-test blood lactate levels. And that might be attributed to the shorter recovery period. So as opposed to the MASRT, which had a 100-second recovery period, the RSA test only had a 30-second recovery period. And so because of that, participants probably had only a partial restoration of PCR stores and a greater reliance on the glycolytic pathway. So obviously, if that's the case, then there's going to be more lactate produced. So conclusions that we can kind of pull from this study. First, that there's limited support for the use of the Wingate as a protocol for testing RSA. Because it had no correlation with the RSA indices, it just shows that it's probably not a fitting test, not only for intermittent sports, because it is a 30-second all-out effort, and oftentimes, repeated sprintability in sports, you may not be moving for that long or, in the same direction and position for that long, but as well as just the mode of exercise. When you're running, you're activating larger muscle groups and it's a weight-bearing exercise rather than sitting on a seat. So yeah, just this article is yet another that kind of shows that the Wingate may not be the most suitable for team sport athletes, specifically intermittent team sports. The MASRT actually may be an appropriate protocol for measuring anaerobic fitness. And then data indicates that both aerobic and anaerobic fitness contribute to RSA performance. And that's because the VO2 max values were correlated with the RSA, but then also the MASRT results had a negative correlation as well. So in terms of practical application for this article and future research, in team sport athletes, both aerobic and anaerobic running tests are going to be more suitable for testing repeated sprint ability than a Wingate. And I discussed this before, but because of the modality of the test, it's going to be more fitting for team sports that are on their feet. But then also, it's going to give a more accurate picture of repeated sprint ability than a Wingate alone. Additionally, RSA performance is influenced by both aerobic and anaerobic factors. So to do a single test and assume that that gives the full picture of an athlete's repeated sprint ability, that's not going to really be as accurate or encompassing as doing multiple running tests like the ones mentioned in this study. And then finally, training protocols to improve RSA among team sport players must include both aerobic and anaerobic drills and potentially include coordination, balance, and muscle strength and power. And that's kind of related to the MASRT test that we mentioned. If you remember in the protocol slide, when we were discussing the details of each test, that did have an 180-degree turn during it. And so authors recommended that including coordination, balance, strength, and power may also improve repeated sprint ability because your ability to do anaerobic drills that are more mimicking of what you would do in a game or during your sport would be most appropriate. And then here is the reference if you're interested in reading the article for yourself. Otherwise, thanks for listening.